Hello guys, welcome back to another video of an average programmer. Today we will solve LeetCode's Delete Challenge problem 3243, which is shortest distance after road addition queries 1. And I'm going to summarize the description for you. And what you need to do is to count the number of minimum steps of going from node 0 to node n-1. You will receive the number of nodes in your input. In this case, we will receive n equals 5, and you will also receive some queries. These queries are going to be representing connections between our nodes. So for our first query, we can say that we will have a connection from node 2 to node 4. For our second query, we will have a connection between 0 and 2. And for our last connection, we will have 0 to 4. Okay, so what we need to do is to count the minimum steps of going from node 0 to n-1, and we need to count the number of steps every time that we are making a query. Okay, so for this example, we can say that we need to make 3 moves going from 0 to 1, 1 to 2, and then 2 to 4. These are 3 moves, so you will have to push the number of minimum nodes to minimum moves, to your result array, and you're going to be doing that for all the queries. Okay, so I hope you understand the problem, but I'm going to be giving you another tip or a particularity or a condition that maybe it's not mentioned in this problem, which is that there are not going to be any connections from the last nodes to the previous nodes. Okay, so you will not have a connection between 3 to 1 or 2 to 0. And that's really important because that is going to be defining which data structure we're going to use. So in this case, we are going to be using a queue. Why a queue? Because we would like to be doing BFS to each node. This is going to be breadth first search, as I mentioned. And I'm not good at programming breadth first search in a recursive way, so I'm going to be leaving the iterating way of this algorithm. And yeah, so I'm going to be explaining you what you're going to be doing. So the first thing that we need to do is to make our adjacency list, and we will have a default adjacency list, which is going to be 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Okay, so I'm going to be representing that through this function. I'm going to put that outside of the main function, so it's in here. You will be creating the adjacency list for the scenario that I already mentioned, and we're going to save that adjacency list in a variable, which is going to be called adjacency list. Okay, so as I mentioned, we're going to be doing a breadth first search because we would like to first try the path added in the query, not our default path. For example, for 2, we would like to go or try first our new connection, which is going to be going from 2 to 4. Okay, so that is why we're going to be using a breadth first search. Yeah, so let me put the function over here. And as I mentioned, we need to initialize our queue. And I'm going to initialize my queue with my first node and also with the amount of steps of going to that node. Okay, so in this case, we can say that going from 0 to 0 costs 0 steps. So that is why I'm adding that to my queue. Okay, and I'm also going to have a set for finding any cycles in my graph. So I'm going to add my set for that, and I'm going to add also the expanded nodes. So this is going to be done through the add function. And as I mentioned, this is the iterative way of making the breadth first search. I'm going to use a while loop, and what I'm going to say is that I'm going to repeat while q has a length bigger than 0. So that is my condition for this, and I'm going to be shifting every time the registers from my queue. As I mentioned, this is the way to do that with the shift function, and I'm going to add the expanded node. So I'm just going to put that in my set, and I'm going to check my base condition. If I'm at the n-1 node, I'm just going to return the length. Okay, and the length is going to be obtained from the tuple that I already explained. So yeah, this is the base case. And I'm going to be doing this for each neighbor of the current processed node. Okay, so if it is not in my visited nodes, I'm going to expand that node and I'm going to push the neighbor and the length +1. Why? Because I already made a move of going from my base node to my neighbor node, so that cost us one action or one step. So that is why I'm adding +1 in here. Okay, so that is actually it, and you need to do this for all the queries that the user is going to be adding. So in this case, I'm just going to declare my result array, which is going to be an array of numbers, and per each query, I'm just going to add the connection to my adjacency list, and I'm going to be doing that through these with these code lines, and I'm just going to update the connections for my node, and I'm just going to push the result of my breadth first search of my graph, and that is going to be all. Let me run the solution, and this should be passing because I already tested it. Yeah, and if I submit it, you will see that it has passed, and the time complexity for this is order of n. I already checked that, so you can believe me. And I'm going to leave also the code in the description box and in the comments so you can check it out. Okay, so that was all, and thank you for watching this video.